So here's another quick problem, looking at problems using a method of ratios to answer them. So this is usually when you get something that's a bit comparative. Can be things like gas laws is quite common, where you get proportionalities as relationships. So for example, with the volume, temperature and pressure. But loads of basically any equation can come up with a sort of ratio style. So it's usually if you've got a situation that's given and then you're comparing something else to it which has some parameters change. For example, how does the kinetic energy of a car change if you double its mass and double its velocity? That kind of thing. So you're looking at either two different objects or two different situations, or a sort of before and after comparison. Okay, so the example we're going to give is just looking at density for a nice simple little question to have a go at. So we've got a density of cubes sides L. We want to know what the density of a second cube would be by comparison if it's got sides L over 2. Now again, it's not a bad idea to always do a bit of a sketch. Beautiful cube there. So we've got L by L by L, and this is cube A. And I've got a second one, which is L over 2 by L over 2 by L over 2. They've both got the same mass. Now, one way to write this would be to call it mass A and mass B, but clearly say somewhere that mass A equals mass B. The other way would just be to call them both M and make sure that you only ever do that if it's the same. If you had two different masses, make sure you always get into the habit of saying things like big M and little m, or M1, M2, or MA and MB. So in this case, I can call them both M. Right, what things do I need to know? And I want to know what the density of the second cube is going to be. Now, it's not immediately obvious that this is a ratio question, but it is a comparisons question, so that should tell you it's a ratio question. You don't have to necessarily do it in this form, but you're going to end up doing this calculation, whatever. So the first thing is to realise, again, create a little list of equations that's going to be useful. The density of any object is its mass divided by its volume. And for a cube, of course, the volume is just L cubed. So this should hopefully tell us that the density of A is going to be the mass, or mass of A, divided by the volume of A, or L cubed. The density of B will be the same thing. It'll be the same mass, but divided by the length of B cubed, which of course we can write as L over 2. Now, where you do this little substitution, it's really important that you do remember to substitute carefully. It'd be an easy mistake to make to leave the over 2 outside of the bracket and end up just with an L cubed and a divided by 2. Okay. The next thing to do is to try and take out this new value that compares or changes this equation to what's on the left-hand side. Now, it's obviously the 2. But this is 2 cubed. So the M and the L are the same as what we had before. 2 cubed is 8. So what I've got is an 8th there. And hopefully you should realise that that 8 will then appear on the top. Right. Now, what you've got to notice is that this part of the equation is essentially this part of the equation in A. So what you can do is you can substitute in PA to that bracket. And this is our answer. This tells us that, I'm saying P, it's rho, but rho B is 8 times rho A. In other words, the density of B is 8 times the density of A. So that's one way of doing it. That's not strictly a ratio. That's more doing it by substitution, but it's a very valid way of doing it. We could do it slightly differently by actually taking a ratio. So let's just do the same thing again, but this time we're just going to take a slightly different approach. So I'm going to answer exactly the same question, but this time I'm just going to do it slightly differently. So again, we take the density of A as the mass divided by L cubed. And again, the density of B is the mass of B, which is just M, L over 2 all cubed. And what we can do is we can take the ratio, and by that, remember, we don't mean something like this. That is a ratio, but not really in physics. A ratio in physics is where you find one thing divided by another. So this is PA over PB, or rho A over rho B. Now we carefully put in the two equations. Right, lots of people get quite confused by doing this sort of multiple fraction thing. So be really, really careful until you are comfortable that you know what you're doing with it. Especially this one, because we've got several layers of fractions now. Okay, so it's worth just remembering that if you've got something like this, the A over B means the B does go on the bottom. The C over D, the C is already on the bottom, but what we've got is something on the bottom of a fraction that's then 1 over. So this D here is a kind of double reciprocal. If you do 1 over something, you just get the something. 1 over 2 is 2. So this is 1 over D. So the D ends up back on top. You need to make sure that you are happy with that before you play around with ratios too much. So back to ours. If we just continue with the right-hand side, we get the M over M. So that's that and that. The L cubed from there goes on the bottom. And I'm just going to move the whole fraction up to the top there. The L over 2 cubed goes there. So I'm just going to simplify that a little bit further. M over M, and yes, I know we can do things with that. Let's get to that in just a second. I'm going to split this L over 2 cubed up and put, again, that 2 on the bottom. So we end up with that. Now, hopefully, we can see that the M's would cancel and the L's would cancel, leaving us just with 1 over 2 cubed. But let's just put the left-hand side back in. And remember that what we've got is the ratio of the density of A to B. So I'm just going to rearrange this now for the density of B, multiplying by the 2 cubed, dividing by leave the B where it is and just rearrange everything around. Two cubed is, of course, 8. So the density of B is 8 times the density of A. Again, exactly what we got over here, but it's just a slightly different way of looking at it. And although the algebra can get a little bit messy because the fractions, it can be a easier way to try and get a comparison ratio between two quantities, rather than trying to do the method on the left, which does involve you having to get something original and do a substitution.